All right, welcome back, friends, to the College of Southern Idaho, Evergreen Building, the geology classroom. And we're going to start our next series on rocks. We've covered just sort of an introduction to rocks. We've covered the igneous rocks and some of the basics of igneous rocks. And so we're going to start our very first series looking at a specific rock, and that is basalt. And I feel like people feel a couple ways about basalt. I know some geologists that think it's absolutely boring. There's not a lot of variety. They kind of roll their eyes when basalt is mentioned. And then there's other folks, of which I'm included, they get pretty excited about basalt. There's a lot of diversity to it. I think people who appreciate volcanoes and get excited about volcanoes are excited about basalt. Of course, where I live here in Southern Idaho in the Snake River Plain, basalt is a ubiquitous rock. It's kind of everywhere. And so consequently, I've got a whole lot of samples to share with you, not just from Idaho, but from Iceland and Hawaii and other places as well. So let's start off. So basalt, we know, is basically what ocean crust is made out of. Most volcanic rocks or eruptions that occur on planet Earth erupt magmas that are basaltic, that become basalt. If you've ever wondered why the ocean is where it is, why is all the water pooled up in those locations? That's because basalt's a really dense material. It's a dense rock. It's much more dense than the rocks that make up the continents, which is mainly granite. And so it forms low areas on the planet. And those low crustal areas are where the water collects. The water that runs off the higher continents collects in these basins where there's a lot of basalt. So that basalt is primarily created at these mid-ocean ridges, at these divergent plate boundaries. So we'll start with some fun facts about basalt, look at some textures, and then we'll so hang with me here for a few minutes while we look at some words, but get some context, and then we'll dig in and look at a lot of rock samples themselves. So it's fun that basalt erupts quite frequently. Usually on planet Earth, there's maybe an eruption, I don't know, maybe 5 to 6, maybe more eruptions per year. And because we can observe these eruptions and they're fairly safe, we can learn a lot about how basaltic lava behaves, how it forms different features, that sort of thing. Remember that fundamentally basalt is just a mafic volcanic rock. That's sort of the definition of basalt. It's a typically dark colored, dark gray to black usually, rock that erupts as magma or lava at the surface. And so that's our definition, but we're going to see there's a lot of variation within that kind of broad definition there. Typically, basalt erupts from what I like to call the nice volcanoes. These are tourist-friendly volcanoes that might cause damage and destruction to property, but people can usually get out of harm's way. And they make really nice tourist attractions. Like this summer when I went to Iceland, I got to watch a really nice fissure eruption from a very safe distance along with a lot of other folks. Shield volcanoes would be the same thing, and then also cinder cones. These are volcanic eruptions that you can appreciate from a safe distance, but actually get pretty close to. So non-explosive, mainly erupting lava, but also erupting to some degree airborne material as well. So our textures of basalt can vary quite a bit. They might be aphanitic. Remember, that's when the crystals are all small and tiny because the cooling rate of the lava is very quick. It might be porphyritic, where some crystals started to form early underground, made bigger crystals, and then those big crystals, as that lava gets erupted, get surrounded by very small crystals. So this is a mixture of big and little crystals. Vesicular, you might remember, are the gas bubbles. So this is when we have a high concentration of gas bubbles in our rocks. We might see that as the dominant texture in a basalt. And there's even glassy basalts, but that's not to be confused with obsidian, which has a different composition entirely. But nonetheless, basalt can be somewhat glassy in the way it presents itself in its texture. So we sometimes use these textural terms as adjectives in front of the word basalt. So we might describe a basalt as being a porphyritic basalt, or an aphanitic basalt, or a vesicular basalt. So realize you can always add those adjectives as description terms before the word basalt there, which is the noun. And then on the last thing on this page is that when basalt is fresh, and I'll show you this here in a second, it oftentimes, not always, but oftentimes is kind of an iridescent color. You'll see blues and purples, maybe some yellows, even greens and oranges, some just sort of a play of colors. But as that weathers, it absorbs more oxygen and more of the iron oxidizes in the basalt. It typically becomes that sort of characteristic kind of black, brown, or even sometimes reddish hue that we sometimes see with basalt. So a couple of variations in basalt that we'll see here. We'll look at some porphyritic basalt. Typically with porphyritic basalt, the big crystals, what we sometimes call phenocrysts, fun word for the day. Usually those are either plagioclase, which remember is a white mineral that has two directions of cleavage at 90 degrees, so it'll tend to form rectangles or squares. The other mineral that's common is olivine, which is that characteristic kind of olive green color. So those are really common crystals to look for in a basalt. If it's porphyritic, it should be obvious to see what kind of crystals it has. If it's aphanitic, you might have to look a little more closely with some magnification. Scoria is a term that's often associated with basalt. This is the term we use for extremely vesicular basalt. So as you pick up a piece of scoria, it probably is really light in terms of weight. It's going to feel light to the touch. But this is different than pumice. Pumice is actually felsic lava. It's from more rhyolitic type of magmas. It tends to be much lighter in color. And so there is a difference between scoria and pumice. Even though the textures are the same, they're coming from different magma bodies and different chemistries. Cinders are kind of commonly associated with basalts. These are just somewhat small, BB to golf ball size. Here's the inches and millimeters here. Pieces of vesicular basalt. So these are common with cinder cones, hence the name. And these are erupted as pyroclastic material. So volcanoes that are erupting stuff up into the air, there's enough gas that it's able to push the material out of the vent into the sky, where it falls back down around the vent and accumulates and piles up. So cinders, another kind of variation of basalt. Basalt often forms volcanic bombs, which are these kind of blobs of magma that get shot out of the volcano, and while they're flying through the air, they actually cool and solidify, and they kind of take on some interesting shapes. I think I've got a video, believe, from Craters of the Moon where I look at a couple volcanic bombs, but I'll show you a couple here. And they need to be at least a couple inches or a couple centimeters in size to sort of qualify as a volcanic bomb. This is sort of a size criteria here. And then lastly, on this page, reticulite. This is a really cool rock. I don't know if you've seen anything like this. I've only been able to find it in Hawaii, but this is kind of a tan, frothy rock. It's actually the lightest or lowest density rock that is around. It's almost completely made out of vesicles. So most of what makes up the rock are holes, and it has these thin glassy bubble walls that form the rock itself. And these are what we typically see when we have very gas-rich lava fountains. So kind of a lava being shot out of a kind of a geyser type opening, a very narrow vent. A lot of gas though coming up with that lava, and this is sort of the frothy material that gets erupted. And then lastly here, I have some pictures, but I'll also show you an actual piece. You've probably heard of this term or phrase before, pillow lavas or pillow basalts. This is when basaltic lava interacts with water and cools very quickly. You tend to get sort of these rounded shapes here. This is from just under the Perrine Bridge here in Twin Falls. You can see actually the conduit that the lava flowed through as it was kind of coming towards you, towards the viewer. And then the edge of this thing tends to be kind of glassy. The interior looks like typical basalt, but it kind of has this rind around the outside. So there's a nice example just here in Twin Falls, and some nice examples here, a photo I took in Iceland of these kind of rounded blobs of lava. But the cool thing about pillow lava is it indicates a clear interaction between the lava and the water. So let's get started. I am using a tripod, which will make some of you happy. I have been paying attention to the comments and trying to do my best here. So this is not necessarily a piece of basalt, but some folks wanted me to talk quickly about ultramafic rock. So this is a piece of peridotite. This is an ultramafic rock. How do we know it's ultramafic? It looks like regular basalt. Well, the composition of olivine in this puts it into a realm where it's considered ultramafic. So this is actually from, I think it's the San Carlos Apache Reservation in Arizona. My father-in-law got this at a rock show And so you can see the nice big sort of cumulates of olivine. So this rock actually came from pretty deep down, well within the upper part of the mantle. So pretty cool, but that's an ultramafic rock, peridotite, if you're interested. And let's just go through, I don't think I have a good order for these. Let's just go through these kind of one at a time and explore each one of these igneous rocks. So here's a nice piece of basalt, a porphyritic basalt with big plage crystals. This came from western Idaho. Sometimes this kind of texture here where you get these plage crystals sort of intersecting. I've heard this informally sometimes called chicken foot basalt, where you get this sort of pattern here. You can kind of see why it would be called that. But you can see these rectangular crystals, the 90 degrees here. So that's a lovely little porphyritic basalt from western Idaho. Moving on. A similar thing, I don't know where this one came from. This was in the collection when I came to CSI, but another great example of a very fine-grained aphanitic basalt, but has these big crystals in it, so we would call it a porphyritic basalt. Again, the big plage crystals, very similar to the last rock, but I do believe this is a different location. It does have a little bit different texture in terms of the size of the crystals. So, whoops, another nice little porphyritic basalt with plage crystals. Let's stay with porphyritic basalts. Let's look at one from Hawaii. We'll zoom in on this one. And here you can see some of these lovely olivine crystals. This is actually from the, I believe it was the 1964 eruption on the lower East Rift Zone on the Big Island, near Cape Kumakahi, if I remember correctly. But yeah, just lovely green crystals. So the story again would be that these crystals formed down in the magma chamber early as slow cooling was taking place, and then ultimately they were carried with the magma towards the surface during the eruption. All the rest of the material, when it erupted, cooled quickly to form the black material here. And there's a few vesicles in here, but we can see that the porphyritic texture is definitely the dominant one. I love this rock. I love these big olivine crystals. They're just so beautiful, just so nice. Okay, porphyritic. Should we do? Here's one more. I suppose this is porphyritic, but it also has a secondary texture as well. I'll zoom back out a little bit. This is definitely a basalt. This is from along the Snake River, maybe about 30 miles west of Twin Falls. Porphyritic basalt with the plagioclase crystals. But the sort of secondary texture here is you come over to this surface here, and if I zoom in, you'll see that it's pretty shiny. You can see some reflective surfaces in here. You might even see a little bit of iridescence, a little bit of color in here, some blues and purples and such, some reflections of the light. This is sort of a glassy basalt on the rind here, on the exterior. Here's a little section with some kind of purples and blues right here. But then the rest of the rock on the interior is more typical porphyritic basalt. So we can definitely see that transition into the more glassy texture as you kind of come up this way. And this is a part of a pillow lava and a lava dam that formed down in the Snake River Canyon. So this lava was pouring directly into the Snake River. More typical kind of aphanitic basalt. So this would be a basalt with very fine crystals. So we can see the weathered surface here doesn't tell us a whole lot, but when we break it open, we can see the crystal size is much smaller here. You can see the pen for scale. There are vesicles in here, but again, those tend to be quite small as well. So this would be more of a classic and typical aphanitic basalt. Same with this one here, although it's a little bit vesicular. So we've got a basalt here with small crystals. You can see them. They're the little white specks in there, but I'm magnified here 3 times. And so these are definitely smaller than 1 millimeter. So this would be an aphanitic basalt with sort of a secondary vesicular texture. That's sort of how I would classify it. Yeah, and someone wrote on it. It's basalt. There you go, number 12. Not my sample. Not sure where that one's from. Let's see what else I have. Let's look at some pieces of scoria. So this is pretty light in weight. And we can see that it's just riddled with these holes, these vesicles, these gas bubbles in the rock. So this is a great example of a piece of scoria or vesicular basalt. Sometimes it tends to be a little bit more red. So here's a piece of scoria where a little more oxidation has occurred, and so it's a little bit more red in terms of its color. What else do we have here? Here we have a piece of basalt that had, well, it had, past tense, vesicles, and that's what these rounded circles are here. But in this case, groundwater has moved through the rock and actually precipitated out mineral material inside the vesicle. So the vesicles are filled either totally, like in this case, or partially by mineral material. And so the fancy name we give these, they're still vesicles, but they've been filled in with mineral material, is these are called amygdules, A-M-Y-G-D-U-L-E. So amygdules are partially mineralized or filled in, or wholly, vesicles. So there's you might call this, here's a good word to impress your friends with. You could call this an amygdoidal basalt. See, I can't even say it, much less spell it, but there you go. So kind of a fun one there. So you can see, and a lot of these are, I haven't tested these. These are probably, there's a group of clay minerals called zeolites. So my guess is these are mostly zeolite minerals lining these cavities, but it could be other things. Sometimes it's quartz, sometimes it's calcite, something like that. We talked about some of the cool colors you can see when basalt is really fresh. So let me zoom back out a little bit here. This is actually from Hawaii. This is a lobe of basalt. And again, you can see how much different the texture is around the outside where it's cooling very quickly in contact with the air versus the interior. The interior looks more or less like your run-of-the-mill basalt, a little bit red, highly vesicular. But as we look around the outside here, we can see that it's glassy, that it also has this kind of iridescent colors to it. So there's definitely a sheen to it. This basalt is, oh boy, when did I collect this one? Well, it's from the 2000s, so it's less than 20 years old for sure. So this is what basalt sometimes looks like when it's brand new on the surface before a lot of weathering has taken place. So some of the iridescent colors, similar sort of thing here, just kind of a small little piece, but you can see again how glassy it is on the interior, and the cool iridescent sort of scaly texture. Almost looks like when it's flowing, it's really cool to watch. Yeah, so there's some of those. Here's a couple cool pieces I collected locally here in Twin Falls that still have some of the iridescence. These are little pieces of cinders, but they have some of those play of colors in them as well. So you can see some of the blues and purples and I guess kind of teal greens in there. Here's another one with a little bit darker colors. There's even kind of some goldish colors as well. These ones don't quite show it as well, but they're a little bit glassy. So yeah, some of the iridescence you might see in fresh lava. Here's another vesicular basalt. Not a lot of vesicles. I suppose this is more aphanitic, but it does have a few vesicles. And some of the vesicles have been filled in this case, with a different crystalline material. I just barely picked this one up. It was kind of back in the corner. I haven't had a chance to look at it much. Could be quartz in there, not totally sure, but kind of cool. So again, an amygdule, I suppose, because you have mineral material filling in a vesicle there. And then some of the vesicles not being filled in. We talked about volcanic bombs. And so here's a nice volcanic bomb. They kind of look like footballs, or I've been told that they kind of look like turds. But these are clots or blobs of lava that are going to spin through the air. So while they're spinning through the air and they're still molten, they're able to deform and take on this sort of tapered shape here. These will actually have tails on them when they're flying through the air. So there typically would be a tail on either side, but a lot of times by the time they hit the ground, this part has solidified, and so these tend to break off. This is not the tail from this actual bomb. You can see the colors are quite different, but this is what might have been attached to it at one point. So these are volcanic bombs, and there's all sorts of different shapes and textures, but this was a blob of lava ejected from the volcano out of the vent, flying through the air, and then it cooled and solidified for the most part before it hit the ground. We see cool ropey structures and textures in basalts. These are oftentimes called pahoehoe lavas from the Hawaiian word. So you can see the interior here, highly vesicular, but then the surface is more smooth and kind of ropey, not unlike this one that we saw here with kind of a smoother exterior surface and then the vesicular interior within. Let's see, and then the last one here, or a couple more I've got here. Here's a piece of pillow basalt. So you can actually see the rind around the outside. If we zoom in here to the interior, it looks like a typical aphanitic basalt, fine grain, doesn't look like there's any big crystals, very few vesicles, if any, or they're quite small. But as we kind of rotate this around, you can see, this is probably a good side right here. If we zoom in on this surface here, get it to settle down, you can see that, hopefully you can see it's a little bit more glassy. This is a little bit more glassy surface in here, a little bit shiny. It has this brown weathering product on it called palagonite. I don't want to get into that now, but this often happens when glassy basalt interacts with water. There's sort of a secondary coating that forms on it. But nonetheless, just a little pillow basalt from here in the Snake River Canyon. And then the really cool one here that maybe you haven't seen before because it's such an odd piece of material. This is reticulite. You can't, it feels like I'm holding nothing, literally. This is incredibly lightweight. You can see the brown little bubble walls. Try to hold that really still for you. But you can see these individual bubbles. You could probably even see my hand kind of through it a little bit, right in this area right here. It's just like a piece of foam or froth. I could literally just crush this in my fingers right now, but I don't want to because it's such a cool little rock. But this is a piece of reticulite that you can find near eruption sites, but it has to be pretty recent, where this stuff would have jetted up in the air, and usually it's hanging out in the little nooks and crannies on the ground. It obviously is pretty fragile, so it weathers quite quickly, but little nice examples of reticulite, kind of an odd piece of rock in the world of rocks. Okay, and then as a big conclusion, I want to show you a couple of my nearest and dearest rocks to me. So these are my basalt babies. So I've been lucky enough to go to an eruption site several times. And so my first time was in 2007. And I was able to stick my rock hammer into an active flowing lava channel and collect a rock to bring back to show students. And so this, you can actually see where the pick end of my rock hammer went into this. So this rock was born in May of 2007. Sorry, I don't remember the date. I'm not a good father. In Hawaii. So this rock is about 15 years old. Then went to Hawaii again in 2014. Had already experienced lava before. And so this was the year I actually took the lava, and I think there's a video on YouTube that shows this, maybe not, might have been the 2007 year, but actually took it in my hands. I had like some leather gloves on and kind of formed it into this ball, kind of compacted it into this chunk here. So this little guy or gal, gender unspecific, was born about 7 years ago or so. And then just this year, the newborn, the baby in the family, is this little chunk of basalt from Iceland. This was formed in 2022, this year in August. A little bit spikier. You can see where the pick end of my rock hammer went into the lava and stuck to it. This is on one of the videos on YouTube. But fun. You can see how glassy they are initially. Really proud of those three little rocks, part of the family. 1, 2, 3, different ages, different places. So anyway, hopefully that was helpful. Gave you some insights into some different basalts. Gave you some information to digest, textures, variation, hopefully things that you can use to identify basalt on your travels and your adventures, or when you're looking at friends' rocks or whatever. But this has been fun, and we'll pick it up next time with another video on another igneous rock. So there you go. Enjoy and have a good one.